proxy pattern is a structural design pattern that provides a proxy or agent object to control access to another object, allowing for additional functionality such as caching, logging, lazy loading, or access control without changing the client's code. So you can see here we have some sort of client object which is trying to reach a target object, but it has to go through this proxy object before getting to the target. So you can see that this proxy is like a sort of in-between object. So let's say that we have an application that fetches a list of YouTube videos from YouTube's API and displays those videos in a list. In our application, we are using a third-party YouTube package to handle fetching the YouTube videos from the YouTube API, and then we render the video on the screen with the video controls. So the problem is that every time a request is made to our application, our server has to re-download the videos from the YouTube API, and this takes a long time, especially if lots of requests are made to our application at one time. So here is the interface for what a video object would look like from our third-party video library from YouTube. So this is an interface called video, and we have a render method as well as a getVideoID, which returns the string ID of the video. And we also have in this third-party package a YouTube video class, which is a class again from the third-party YouTube library, which essentially creates YouTube video objects by fetching the video from the YouTube API via its video ID. So in the constructor you can see here that we pass the video ID that we want to fetch from the YouTube API, and then the video starts to download. So as you can see, whenever we create a new YouTube video object, it downloads the whole video. And as you can see here, we just log downloading video with video ID from the YouTube API. And then we also have a render method for rendering the video onto the UI, and we also have a method for getting the video ID. Okay, so that is basically the sort of third-party package that we would be dealing with for YouTube. So let's actually now create the code that would be part of our source code. So we're going to create a class called video list, and this is outside of the YouTube third-party package. This is our own sort of custom code now, and we're going to have a dictionary to store a list of videos. And then we're going to have an add method for adding a video to this list. And this should be a video.getVideoID. So it looks like I've imported the wrong type of video here. So let me import the correct one. So it should be from Proxy, Bad, Example, and the third-party package. Okay, so now we should be able to get the ID. There we go. And we're going to pass in the video. Okay, so as you can see, this dictionary has a key, a string key, and the string key is going to be the video ID, and the value for that key is going to be the actual video object itself. So next thing we want to do is we're going to create a method called watch. And this is going to take a video ID. It's going to get the video from the video list. And we can do that by accessing the video ID value. So we're getting the video at this key, and we can then call video.render. Okay, So that's everything we need to do in our video list. So we store a list of videos with a string key, which is the video ID, and then we store the value as the actual video object itself. So let's now take a look at how we could use this solution inside of a client. So first of all, let's create a video list. And then let's create a sort of list of video IDs. And let's call this video IDs. Okay, so just some random strings there. And then let's loop through these video IDs and add them to our video list. Okay, so here we loop through all of our video IDs, and for each ID we are adding to our video list a new YouTube video, and we pass the video ID to the YouTube video class, and if you remember, this class will download the YouTube video whenever we create this YouTube video object. So it automatically downloads. Okay, so then what we can do is let's actually watch a video. So let's say we want to watch the video with ID ABCDE. So we can say video list dot watch, and we can pass the ID of the video that we want to watch. So let's run this now to check that it's all working correctly. And we can see that we are downloading all of these videos. So 1, 2, 3, 4, A, B, C, D, E, and Java SC 1, 2, 3, all being downloaded, and then we render the video with ID A, B, C, D, E. So this one is ready to watch on the screen. Okay, so just adding a video to our video list causes that whole video to be downloaded. So even if the user doesn't want to watch that video, it's still going to be downloaded. And the user here only wants to watch the video with ID ABCDE. So it will be much more efficient to download the video only after the user has selected a video from the video list. And this is called lazy loading, or delaying the loading of something for when it's actually required. So the problem is that our YouTube video class is from a third-party library, so we're unable to modify its source code. So the solution to this is to use a proxy object, which we create ourselves. So you can see here that the video list, our video list, is no longer going to be talking directly to these third-party YouTube video objects. Instead, it's going to be talking to these video proxy objects, which we are going to create. And these video proxy objects are going to lazy load these YouTube video objects. So here is the UML for the solution that we are going to come up with. So as you can see, our video list object will now talk to video proxy objects instead of these third-party video objects. And this UML shows that our video proxy object will implement the third-party library's video interface, which is this interface here. So this comes from our third-party package, and this means that we can add these video proxy objects to our video list, and video list won't care whether it's a third-party video or a video proxy, as long as it is of type video. So you can see here that video proxy, which we're going to create, and the third-party YouTube video class both implement this third-party video interface, meaning that they can be treated the same in our video list. So now inside of our video list we can add video proxy objects instead of our third-party YouTube video objects, which gives us some control over when the video is downloaded. So inside of the render method of a video proxy object, we can see here, we can check if the video field is equal to null, and if it is, we then create a new YouTube video and then render the video. So now a third-party YouTube video is only going to be created when the render method is called, which means that when the user actually wants to watch the video. So no videos are going to be downloaded until the user actually wants to watch them. So here is the Gang of 4 UML for the proxy pattern, and as you can see, we have our client, which is talking to a subject, and we have a real subject and our proxy object. And you can see that the proxy object both implements the subject just like the real subject does, meaning that it can be treated the same as the real subject in our client. But it means that we can also run some custom code before we call the real subject's request method. And some things that we might want to do are lazy load or cache and or log some information before we call this request method on the real subject. So let's now implement this proxy pattern solution in code. So the first thing that we're going to do is we are going to create our YouTube video proxy class. So we're going to come into, we're not going to make this inside of the package, by the way, because this is our own code, whereas this package, remember, is our third-party library code that we wouldn't actually have access to in a real application. So let's go ahead and create the YouTube video proxy class. And this class needs to implement the video interface from our third-party library. So we have a lot of videos here, so I believe it could be any one of these. Let's try this one. And okay, is this correct? Okay, I think that's correct. So yeah, we are implementing the video class from our third-party YouTube package, and then we need to actually implement the interface. Okay, so inside of this class we need a couple of fields. So first of all, we need a video ID field, and we also need a field for storing a reference to the actual YouTube video, and this is going to be of type YouTube video from our third-party library. So I've been a little bit inconsistent here with capitalizing the T's, but it'll be okay. So let's now create a constructor so we can pass in the video ID for the video that we want to download and watch. So we're going to create a public constructor called YouTube video proxy, and we're going to pass in the video ID. Okay, we're not passing in a video. Okay, so now what we need to do is let's actually return the video ID here, and then implement our render method. So inside of render, we want to actually lazy load the YouTube video. So if I just quickly show you what a YouTube video looks like from our third-party library, you can see that the YouTube video is downloaded as soon as we create one of these YouTube video objects, and we want to lazy load the video. So you can see here, whenever we create a YouTube video proxy, we just pass the video ID and we don't actually create one of these YouTube video objects, because if we do, it's going to download the video, and we only want to download the video once this render method is called, which means that when the user clicks on the video to actually watch the video. So what we can do here is we can check to see if the YouTube video is equal to null. So let's check if video equals null. And if it does, we can then set YouTube video equal to a new YouTube video. And in here we pass the video ID that we want to watch. Okay, so this means that if the render method is called multiple times, then it's still only going to download the YouTube video once. It's only going to create this new YouTube video one time, because once this has already been called, YouTube video will no longer be null. Okay, so finally we can call YouTube video dot render. Okay, and that's going to render the YouTube video. So we are now lazy loading YouTube videos with this YouTube video proxy. So now that we have these video proxy objects that implement video, we can now in our client, we can add these proxy objects in place of the real YouTube video class. So here we are adding YouTube videos, but instead what we can do now is add YouTube video proxy objects instead. So let's do that. And what we want to do now is get rid of our previous example code. Okay, so this all looks okay. So that's all we've done. We've just changed this from YouTube video to YouTube video proxy, and our video list doesn't care whether we add YouTube video proxies or whether we add real YouTube videos, because as far as the video list is concerned, they both implement the third-party video interface, and it can treat them as the same using polymorphism. So now let's see what happens. Okay, so when we watch the video, we can see that the video is downloaded from the YouTube API and the video is rendered. But if I comment this out, let's see what happens. So you can see nothing is logged to the console when we add videos to the list, whereas beforehand, if you remember, let's actually show you what happened beforehand. So YouTube video, and let's play this, run this. You can see that even before even if the user doesn't click on one of these videos to watch them, whenever we add them to the list or create one of these new YouTube videos, the video had to be downloaded from the YouTube API. So this would take potentially quite a long time. Whereas now, using the YouTube video proxy, you can see that no videos are actually downloaded until one of those videos is clicked on or the user wants to actually watch one. So the video that we want, the videos are now lazy loaded. So the only video that is actually downloaded is this ABCDE video, because the user actually wants to watch that one.